Hey folks, welcome stpete.net meetup. This is our first purely virtual meeting. We'll give it a few more minutes and we'll see if anybody else joins the chat. Yeah, sorry folks that we don't have any pizza to offer everybody. We are still looking for speakers for next month. So if anybody wants to volunteer to speak or have any suggestions on topics, then we'd certainly welcome any and all suggestions. We'll give it another minute or two and let everybody join the chat.
How many people we got on right now?
We got about 10.
Anybody who's on, tweet people you know, tell them that we're doing this.
Yeah, be sure to grab the link to the Twitch channel, tweet it out, and invite everybody on. We would really appreciate it. And let us know if you like this format. We can try different things while we're still in lockdown and remote as we are. If you've got specific questions, everyone is monitoring the chat room. Chris will have the chat open as well. So as he starts presenting, then he can look to answer your questions. If he misses them, then we'll interrupt him and ask and call his attention to it as well.
Yeah, I'm okay with this being a little interactive. If you guys have questions, feel free to answer them, or ask them, and I'll try to answer them.
I like the first option. That was pretty cool.
Yeah, just ask and answer your own questions. That makes my job so much easier.
We were, before we actually started broadcasting, we were noticing the books behind Chris and trying to pick out the latest or the oldest, earliest technologies, the most faded books.
Yeah, I used to be a strong Linux admin guy, so there's a lot of Sednock and Perl up there. There's some CGI bin. Yeah, I think I might have an HTML3 book somewhere.
Wow.
There's an HTML4 on the side.
All right, we've got a viewer from Tallahassee.
Well, there's structured COBOL, so that's pretty old.
And might be might be in high demand right now. So
yeah, I do have the Lions book, the annotated Unix kernel. It's a reprint from the 1970s, but it's good. One of the oldest is probably the Mythical Man Month, Brooks.
Mm-hmm. Is that old? I know it's
he wrote it after the design of the IBM System 360. That like this was written in the 70s time frame, and it's the themes and the problems that he identified then, we are still dealing with 40, 50 years later.
That's actually a good idea. I'm going to post it to LinkedIn as well.
My name, Chris.
Sorry, somebody mentioned they found it on LinkedIn.
And I'd like to talk about the dependency injection in .NET Core, and I'll dive into a little bit more in the talk. Especially with .NET 5 coming, which is the unification of Framework, Core, Xamarin, and, Mono, and all the things. I think there's going to be an influx of developers who've been mainly on Framework, and I know in Framework for many years, you would roll your own dependency injection or pick a library or something, and understanding that it's baked into .NET Core, and Core is taken 10 years of lessons learned and has an opinion about some things like dependency injection. I think it's good to kind of refresh that conversation. So
All right, it's about 5 minutes past the hour, so we can look to start getting started. Um, like I mentioned before, if you're just joining chat, we do have the chat windows up, and we can answer questions as they come up. Chris will have the chat window open as well, so if he sees something going on during the presentation, he can answer it. If he's missed it, then maybe we'll try to interrupt him and call his attention to it. If you like this format, let us know if there are things that you think we could do differently that would help. We're certainly open to any and all ideas. I was just thinking that maybe we might figure out a way to do sponsorships and giveaways and things like that. So if anybody has any ideas or suggestions, or anybody wants to contribute in some form or fashion to sponsoring or giveaways or something like that, then let us know. But with that, we'll go ahead and get started. I'm John Calloway. I'm your host. Clayton Hunt is our co-host, and he's handling all of the technologies and streamings and things like that for us. So appreciate that. Today we have Chris Ayers talking about dependency injection and unit testing in .NET Core. So Chris, I'll let you introduce yourself and let you take it away.
Sounds good. Thank you very much. So I am sharing my screen. Can you guys see that?
Yes.
Okay. Perfect. All right. So I am, my name is Chris Ayers. I'm the DevOps lead for North America in New Signature. We're a Microsoft partner, and we're also a GitHub partner. You can find my LinkedIn and Twitter right there. And I'm going to have a couple of sample projects just to highlight a few of the things I talk about as we go through. So there's my GitHub. Feel free to poke around, submit a pull request if you're so inclined. This is not just going to be a presentation. I want to show some code and some working things that you can play around with. And I'm also going to have some links to resources at the end. I've been developing professionally since the 90s. I've been a .NET developer since one, and I've been in the cloud for years as well. So I've been doing this a long time, and I've seen a lot of different patterns and tendencies over the years. And as I was saying right before we started, when I did a lot of development in framework and MVC and web forms, at the time you would pick a lot of your own dependency injection frameworks. It wasn't necessarily built in readily to leverage with all of your own services and configuration. That changed with .NET Core. They started having some services provided for you and leveraging dependency injection, logging. And as we move forward, by the end of the year, we should be on .NET 5, which will unify core and framework and all the other pieces. So this might be a great chance for people who are used to framework to learn some of the new capabilities that they might just be exposed to. And if you're already in .NET Core, there might be some features there that you haven't played with. So there's two main topics we're going to talk about today, and I kind of talking about both of them because they go hand in hand, dependency injection and unit testing. So for dependency injection, why do we care about it? Well, one, I think it provides a lot of clarity to our code. It's very explicit about the dependencies that we use, and that makes our code more maintainable because it's easier to understand. By isolating out our dependencies, I think it makes our code more reusable, makes it more modular, it makes it more testable, which I will show you. And it lets us actually use different implementations. This is where some of the design patterns come in. They've been going around for years, the Gang of Four through Java, but those patterns still apply today. We're going to talk about solid principles a little bit. Single responsibility principle, the open close principle. So single responsibility, a class should really only do one thing. Open closed, it should be open for extension but closed for modification. List substitution principle, which I see I have a typo there. You should be able to substitute one class for like a child class as long as the interfaces match. Interface segregation, you should depend on interfaces and abstractions and not concretions. And then dependency inversion. Oh, I got them backwards. You should um, be very specific with your interfaces rather than general purpose interfaces. And then dependency inversion, you should depend on abstractions and not concrete classes. So there's some design patterns that apply when you're starting to use dependency injection and actually come into play as you start evolving very tightly coupled code to more loosely coupled code. Maybe we have this facade or a factory class, or we're going to try to do a strategy pattern or a visitor. A lot of these patterns that we've used for years still come into play and actually leverage those interfaces that we're going to be designing through dependency injection and open themselves up to more testing. So for the facade pattern, just to quickly touch on it, if you have some really complex operation that requires multiple classes, multiple subsystems, and some orchestration, if you wrap them in a facade class, you can have one dependency on the facade and have it handle a lot of the orchestration. And so you can hide those client details from your client and let the facade deal with the orchestration and all of those details, and you can just depend on the facade or the factory. You want to know how to make an object, and there's a lot of similar objects, and they might have a special configuration. By going through a factory and depending on just an interface, you can let the other class handle the construction of that specific type and just give you an interface. And though this one and the strategy pattern. So I want to be able to do an action, and maybe there's a couple of different ways. I've seen the strategy pattern demonstrated with navigation. Maybe you want to have some different sort of navigation methods or whatever. That's your strategy. So I just say I have an interface that implements that strategy. I depend on that interface. Doesn't matter which one gets plugged in. I have an interface that has the method I want. I call that one method, and it works. So these are some reasons why and some patterns why we might want to leverage dependency injection. Let's actually dive into it and what it looks like. And I have some code samples, but I have a couple slides first. So if we're not using dependency injection, a lot of times things I've seen in code reviews and in architectural reviews are we're newing things up. So in this constructor here of this client service, we're newing up a new repository. It's not super obvious that I depend on it, but you see it in the constructor. So you're like, okay. But if you look farther down, inside some of our methods, we're newing up other services. So if I just look at my constructor, it doesn't tell me I depend on that other service. And also, if I look, there's like an email provider.send. That could be a static. So I might have no idea. I have a dependency on something else. And I pull it down, I pull audit, I put client, and I try to build it. And I might have failures and a hard time getting it working. One of the styles of dependency injection is properties. So I can list out all the things I have as properties. So maybe I list out my audit service and my email provider. This is a little bit cleaner, but the property injection, you can't guarantee that they've been created. When you go through a constructor, it's been constructed. If it's some property that's hooked into your dependency framework, at some point, hopefully somebody will assign that audit service a value, but you can't be sure. And so now we have to add checks in our code to see if it's been checked and initialized. And this can be good if you have really big complex creation processes or a big pipeline. I'm not a fan of this personally. There's method parameter injection. So maybe, you can see we're starting to put our properties into our constructor, and I can see easily I depend on a client repository and an audit service when I'm trying to build my thing. Maybe that email isn't needed for the whole class. Maybe it's really only needed for one method. So there are cases where maybe I just inject the thing I need only on that one property. I really don't have a lot of problem with that, but this is definitely a style. I usually, typically, what I do is if I depend on it, I put it in my constructor. I want it to be very clear and explicit what the class depends on to operate, to work successfully. And because everything is an interface, none of these are concrete classes. Everything's an interface, which means I can easily mock it and stub it out. Yeah, I will try to slow down a little bit. Sorry. Um, this is just an example that really doesn't mean much. But if I go back a slide or two, sorry about that. Let's say I have a client service that I want to delete a user or some entity, and I want it to audit that it was deleted, and I want to then delete that object, and I want to send an email that it was deleted. Here, you can see I'm doing things. I'm leveraging a private object, and I'm calling a static. That is confusing to me when I start reviewing it. There's some context on like where is it coming from. This one where we're doing the property injection, because I don't actually new up or create the audit or the email provider. I don't know where they're coming from. Something outside's coming, putting them in, but it's not doing it at construction time. It's doing it later between construction and my call. So that's why I have to do the tests to then kind of log the delete or send the email. In this one, these are read only. These are created during the construction. So I know it's guaranteed to exist. So I don't really need the tests here. Yes, we're gonna talk about scoping in a second, so it's gonna be great. But we still have to kind of check maybe was that provided, was it not null, because that's a parameter. And in this one, I might have a null check in my constructor, but it's guaranteed. Um, yeah, it's guaranteed hopefully to be provided. So we talked about some of the patterns, and we talked about some of the types of dependency injection. And this is where you have that code that's very tightly coupled, and we start maybe making a factory. So instead of me newing up my classes, I'm having a factory make my classes. So I'm kind of pulling apart my code slowly. Then maybe I'm starting to do dependency injection by adding interfaces. So this is a way from when your code news up everything to now my code is asking for an interface, and now we can start implementing dependency injections. And then this is the last thing I'm going to touch on when we get into the code. We're going to use an inversion of control container, an IOC container. This is what is used for a lot of the dependency injection. It's called a container. So I'm going to show that in just a moment. There are scopes, as someone in the chat mentioned. So in .NET, there are three kind of basic scopes built in. Transient. So every time you need a dependency, every time you need a class, the container, will make you a new one. So every time you call it, you'll get a new copy of that dependency. Scoped, now that can be like scoped to a web request. So in the process of a web call, anybody in the chain of code that says, I need a new logger or I need a new whatever service, they will all get the same one for the context of that web call. And I'm going to show this in an example in just a moment. And then singleton, this is that old favorite massive global variable that lives on forever. There's a single one of it. You have to be very aware of thread safety whenever you're thinking about singletons. I try to avoid singletons whenever possible. So dependency injection. So we're going to talk about a couple of things. So the composition root, that's that container. That's the thing that you tell it, here's how you make my services. And later on, when they need a parameter, the composition root's going to new it up for you. They can live with configuration. So we can define configuration in different ways, and we can inject configuration. We can tell it the scope, and it works with factories. There are a number of types of dependency injection frameworks. Some of these are older, some of these are newer. They are all well documented out on the .NET website, and I have a link to that in just a moment. But I want to get to actually bring up some code and show some things. So if you go out to GitHub, I have a DI example project, and this is a .NET Core application. And if we look in startup, you can see I have a bunch of stuff. So I have a transient operation that I said, hey, anytime anyone asks for an I operation transient, give them an operation. And all this is doing is saying, make a new one every request, or every time they ask, make a new one. This is for the scope of the operation, make the new one. And this is make one and just have it live forever. And I just want to show you kind of what the scope looks like inside of .NET Core. And I'm just generating some GUIDs, and I'm gonna spit them out onto the screen. Another thing you can do is you can have nesting, so you can have like a subscope, and I'm gonna show that right as soon as this loads. And while this is coming up, if there's any questions about what we've covered so far. All right, so this is a very basic app, but looking at the scope, we have some GUIDs, and I want to call this out. So I have a dependency, and then I have a service that is underneath my dependency. You know, like I need that service. So in both of them, when I have a transient, okay, let me do, thank you. There we go. Is that a little bit better? Okay. So when it's a transient and I asked for a service, it doesn't matter who asked for it when, they each get a unique copy. When it's scoped for this, the purposes of this request, they're both going to get the same object. And then for the singleton, they're both going to get the same object. Well, this example actually has another level. Let's have a subscope, and let's just kind of take a look a couple levels deep. So for the transient, everybody gets their own copy. They're all different. For the scoped though, the parent ones, they both have the same object, and the subscope has they both have the same object because those are scoped together. And the singleton, I don't know if you remember the DD93 from the previous screen, the singleton is the same one everywhere. So for scoping for scoping purposes, transient is great when you're doing stateless stuff. Scoped, it can be good if you have to have some things last for the state of the operation. And then singletons are singletons. They kind of live forever. Let me try to make this a little bit bigger since, yeah, okay, that's not a good one. Let's not do that. Let's try doing that. There, can you guys read that? So this is where I define them. So these are defined in your startup CS and configure services. And I have a couple of different ways options are defined. Like you can even configure some of them. So this configure options and configure my option stuff. These are actually pulling from the app settings. So we can set some of these values, and they will be the configuration will define that option, and that can be passed to different services. And I did show that example I was showing before. I just wanted to kind of highlight real quick before I dive into some of the testing. Again, I just wanted to briefly dive into dependency injection, but here's where we have maybe some dependencies, they're allocated. We have some classes that do some stuff. And if I go look at the audit service, you know, it's just a class. You know, I don't have a lot of stuff wrapped around it, but this is a static class with a static call. As I start implementing dependency injection, maybe I start creating some interfaces. And so I can easily see what different services do and what operations they have so that we can mock and provide and test those. And then that static class, I might wrap it with something so that I can at least mock it out, kind of start pulling it apart before I rewrite it completely into a non-static class. And then when we get to that dependency injection type of implementation, everything implements an interface, and it makes it pretty clean what dependencies are needed, and I can understand a little bit easier what the code's doing. So now there's some great resources. I want to make sure, because I want to focus on the unit testing side, but I wanted to make sure that there's some good like groundwork for when we talk about the testing. So there's 3 links, and I'll make sure these slides are provided so that you guys can review them later. Dependency injection in .NET Core. This link is hosted. This is on the Microsoft website, the docs.microsoft. This is actually hosted on GitHub, so if there's a typo or an issue, you can look at it. And they have a discussion of dependency injection. They talk about some of the framework provided services. So, oh, there we go. A little too much. Sorry about that. Framework provided services. So, like the loggers and configuration and diagnostic sources, how they can be injected and what style of lifetime they have, additional tools. So this has some great resources if you want to use those. Also, iDisposable. So when the container creates objects, a lot of times it will try to dispose of them through iDisposable. So if you start implementing classes that need to hold on to stuff or create resources, you might want to make sure that they do iDisposable. So kind of just want to have a groundwork. Are we good on where dependency injection kind of lives and why we why we want to have it to start separating our code so we can make it more testable? So that helps us with our decoupling, and dependency injection is a great way to achieve decoupling. So let's talk about testing. So there's a lot of terms that come up when people talk about unit testing. Sometimes people will refer to things as a SUT or a cut, and those refer to the system under test or a class under test. When you're testing, it's very important to try to isolate one class or one thing. I've been at too many places where people end up unit testing their fake code, or their tests are calling out to the database or making web calls, and they're more integration tests than unit tests. And just to make sure that we're good with our vocabulary, test doubles are pretty much anything that we're going to use when we're testing. So it can be a fake or a mock or a stub or spy or whatever. It's something that we're going to substitute to try to make the behavior better for testing. A fake is usually something that doesn't have a production quality implementation. It might be, that database repository might be backed by a linked list in memory very quickly thrown together, or it might always return. So a mock, for instance, will have some behavior, and there's mocking frameworks so that you can call things and verify they got called and modify how they respond. Stubs will a lot of times just return static values. So you say get user and you get a faked out user. Spies, a lot of times this falls in with mocks. You want to know that something got called. Like I want to verify this got called 1 time or 3 times. And then dummy objects, just we're passing values that don't mean anything to get something to get called properly. So these are some terms that we're going to touch on. Unit testing architectures. So the very easy to test architectures usually have IOC, inversion of control, where we've set up that interface segregation. We're doing dependency injection. Something else that's very, very easy to test is functional programming. Functional programming really, one of the core tenets of functional programming, or like at least pure functions, are to not have side effects. And so a lot of times all of the parameters needed to do their operation are passed in. So it's very easy to unit test it, functional programming. Hard to test code, everything's just this ball of spaghetti. It's very tightly coupled. They depend on classes and like explicit, that implementation of it. You have a dumping bag of classes where you have methods that do all sorts of things that don't even try to follow a single responsibility. When they lie about dependencies, uh, I know I've seen this many times where you start trying to test something and there's a static call 4 layers down that you didn't expect, that wasn't called out, that's just hidden, or stuff that's very hard to understand or maintain. Um, Adding unit tests after the fact is hard and not very effective. So typically, how I lay out my tests are, if I have a couple of libraries, I have a couple of unit test assemblies. I don't put my tests in the same assembly or class as library as the class lib. I have a separate one. I name them very similarly. I want to know that if I have a foo.test failing test, that I go look in foo. Um, if I have a couple of classes, I like a.cs, I have a unit test class called atests.cs. I know it really confusing. If I have this nested folder structure, which I will show in a minute, like a controller inside of a folder, I would have a controllers folder and have a test inside of that. So it's very easy for me to navigate back and forth between my tests and my classes. You don't have to do it this way, but this is very effective for me and some of the coworkers that I've worked with over the years. Um, like I said, have consistent naming. So I always name my test class after the class I'm testing. Like I said, foo into foo tests. And I always name my unit tests after the method and then the condition I'm trying to test and the expected behavior. So in the example here, get lines. So in my foo class, I expect I'm going to find a get lines method and I'm going to try it with 2 line strings and I expect it to return 2 strings. When I see this big list of unit tests and I'll see a failing test, I can easily know what class failed, what method failed, and what condition failed just by reading the name of the test. So this can give me quick, knowing exactly where I'm going. Um, there's a couple of different unit test frameworks that are out there, NUnit, XUnit, and MS Test. They all work fine. They all work well. Um, NUnit also works with um, Cucumber and some of the automated acceptance testing. All of these work great. I'll show a couple examples. Then when we get past the unit testing framework, sometimes we want to mock some code. So there's a couple of ways to mock code. These are pretty popular. I use mock, MOQ. I know some people that use nsubstitute or just mock. All of these are to help take an interface and you say new mock and you kind of throw it off to mock or fake or whatever, and it will make a class that implements that interface and you can pretty much do whatever you want with it. Say when somebody calls X, do this. And I will show an example of this. Couple of gotchas I want to touch on. Most mocking frameworks and most unit testing only works for interfaces or virtual methods. So if you have to deal with statics, a lot of times you're going to still call the implementation of the original class. An example of this can be like daytime now or UTC now. Don't use daytime now. That is static. Like it is really hard to wrap that or test that. So interfaces, virtual methods, those are things that you can easily mock. There is a library called Fakes I've used in the framework. I haven't tried it in core, that would let you stub and shim statics. And you had to have Enterprise to do it. You had to have Visual Studio Enterprise to do it. So it did not work with Community or Professional. Also, when you're mocking things, it can make some big assumptions about how code is architected and what the boundaries are. And by boundaries, I mean the responsibilities of calls and methods. And then some best practices. So I'm gonna try to show you these, but AAA. This is like, to me, the golden rule in a lot of unit testing. Arrange, act, assert. So in my tests, I clearly say I'm setting up my test, I'm doing the action I want to test, and then I'm checking the results. Having that delineation makes it very clear what I did to set it up and what I was expecting at the end. I try to assert one time per test because I'm checking one thing per test. I don't have a lot of test interdependence, which means this test has to run for that test to pass. That means I'm setting something up, or I have side effects, or I'm doing something I didn't realize. If your test is super long, you're probably testing way too much, and you probably have some pain in setup. And setup pain can really lead to some questions about, is our class too big? Is it doing too much? And does it have too much dependency? And finally, add them to your builds. Run them on every check-in. Run them on your pull requests, please. So let's go look at some tests. We want them to be fast, isolated, repeatable, and self-checking. And timely means we should be able to get responses pretty quick. So let's go take a look. This one I'm bringing up in Visual Studio Code. So let me try to, there we go. Make this a little bit bigger for people. And I will show you this in the pipeline. I have it both running as a GitHub action and as a Azure DevOps pipeline. So I'll show this running in the pipeline. But so we have our demo class, and this just has, let's say, some controllers. Okay. Down here under tests, I have my demo tests, and I have a controllers folder. And I have up here under controllers, I have a book controller. Down here under my test, I have book controller tests. So for me, I have them both very parallel in their layout. Let me move that out of the way just to kind of talk about what's happening. So for my way of doing testing, I have a private, this is my system under test, my class under test. I'm trying to test the book controller. And I know that the book controller takes a mock service. There is a functionality in testing where you can have a setup or initialize method, and it's called at the beginning of every test. So if I have 5 tests, before every test, it will run test initialize. And so because I have this variable and I knew it up at the beginning of every test, I have a fresh, untangled object that's not impacted by any of the other tests. And a lot of times, first thing I'll do is write a test for making sure it returns an object. If you start going with something like test-driven development, a lot of times you'll write tests that won't compile or work, and then you'll go and do some more stuff to make them compile but not pass. They'll fail, to make sure that you have a valid test, and then you'll do stuff to make them pass. And you can see I've set up a service here. So this is where I'm using mock, MOQ. Where when you say this is a new mock, it gives you this setup method, and you can say in very fluent style, anytime somebody calls get all, return this list of books. That is what I'm doing. So I'm arranging, I have a book list with one test on it, and when somebody calls get all, it's going to return the book list. And so now I'm doing the act. I'm hitting the index on that book controller, and I'm getting a view result. And I can verify, hey, there's a model, and it's a type of a book list view model. And then I can verify the behavior. I've called that index. I want to verify get all got called one time. So I'm verifying that when I hit that controller, it went down into the service and called that method. So this is kind of basic testing. What I see some problems people have a lot of times is their database testing. They try to test getting calls back from a database, and they end up integrating with an on-prem database or on their own server. So I have some data tests, and I actually split up my project a couple of ways. So in my data project, I try to split the domain objects, which are the core of my application, like a book. So I have a book, and it has a reference to an author. I have a book. And I usually try to separate that from my entity model, which is what's in the database. So I need something to connect my book domain object to my book entity in my database. And so I have adapters. These go back and forth between a book domain object and a book entity object. And a lot of times what I see is, you have something like AutoMapper mapping DTOs, and people might forget a field or parameter. They set up a new mapping, they add a new field, and they forget something. So I want to test my adapter. I don't need to test that the database can return data. I want to test my adapter. So if I go down to my tests, so I have my book domain to entity adapter tests. And this just makes a new adapter. This is kind of functional. So I can say, hey, given a null book, null item, adapt it, I get a null one back. Make sure that the empty case works. So now I'm doing an adapter, and when I pass in an ID, those map. When I pass in the title, that maps and they're equal. So I'm verifying that my mapping code doesn't forget anything and that everything's been moved over properly. So I can fully test my DTO to entity. Okay, well, how do we test our database? Well, I don't really want to test my database, but if I was going to test my database, Entity Framework has a couple of things that they can do to leverage some NuGet packages you can add. One of them is an in-memory database. So I can say I want to use an in-memory database, and I can give it my context and a string that says this is the in-memory database I'm using, and I can give it, I can manually interact with my data like it's a database in memory. So I can take that list of stuff and I can add them to my database context and save the changes. And now that everything's in that in-memory database, I can query and interact with it like it's a real database. And I don't have a dependency outside of this code base. I don't really like this a lot. I mean, this works, but if multiple tests use the same in-memory database, you can have side effects and some strings. There's actually another way, and I came across this and I love it, and I love to share it with people. And so the first way is you can create a mock DB set, but you have to define iQueryables on your entities and set up these 4 properties: provider, expression, element type, and enumerator. And now what that means is I can take this list of books that I just have in my code as queryable, and I can say, return that mock set. Here's my book. I'm using the iQueryable providers from my as queryable up above, and I can kind of wire up an in-memory list as a DB set, and I can just make my repository with that, and I can just run normal repo stuff against an in-memory list. So I think this is awesome for some of the testing. I just really don't like this setup. So then I found another library just to share that makes it even simpler. So there's a guy out there that has written an amazing library, and I'll make sure I have a link to it, called Entity Framework Core Mock. I had that working in .NET Core 2. He's updated it for .NET Core 3. So this is Entity Framework Core 3 Mock. And so now I have my list of books. I do the as queryable, and I just say, hey, make a mock, set that mock equal to the books and wire that into my repo. 2 lines of code instead of like that 8 from before. And I think that's much cleaner and much easier to read. And the test still work the exact same way. And pretty much everywhere you can see I'm trying to arrange and act. And because I'm resetting everything on my new test initialize, these are all independent. I'm using in here Visual Studio Code, and there is a Test Explorer extension for it. So I can go look at my tests, and I can run my tests, and I can do all my tests here. This also applies to Visual Studio. If you guys use 2019, I can open my solution in Visual Studio. There's a lot of cool functionality that they added. If you have professional and enterprise, one of them, and I'm not sure if it's in community. They added live unit testing, so you can tell it to run all your unit tests, and every time you make a code change, it'll rerun all your unit tests. So you have a constant understanding of if your tests are passing or failing. Okay, there we go. It opened. Sorry, I have a lot open on my machine right now. So live unit testing, that's something that's been added. That's pretty nice, and you can start it up and it will just kind of constantly keep running your unit test in the background. And not only that, it'll highlight the lines that you're testing and not testing. So it's very nice. But like I said, we want to make sure our tests are run in our pipeline. So if we go out here to our pipelines, all this code again is hosted out on GitHub, and I've got the unit testing demo and the dependency injection demo. This, as I said before, was set up to run in GitHub Actions. So you can come out here if you're curious about how that runs. You can see it it builds and it runs our tests. So you can see all the tests. Git run, and that's nice. I've also set it up in Azure Pipelines under Azure DevOps. This is, I believe, a public project, so you can come out here and look. You can see my test runs, and I can see, if they failed, when they were failing, and how long they take to run. And you can see, looking at this, I would kind of know pretty quickly, what's going on, and I can dive into some of the attachments. But one of the nice features that they've enabled through Coverlet and some of the documentation on it is looking at code coverage of your project. And I can dig into like different pieces of the project and see what's been covered, what's not been covered, and how many times it was covered. And so I can get a better picture. One of the things they've also added to Azure DevOps is they build quality gate. So you could say, hey, if my tests fail, go ahead and push the tests up here so I can at least report on it. Run the code coverage. If the code coverage is below a certain percent, fail the build. Or I want you to keep improving code coverage until it gets to a certain point, and then I don't care. Build it up until it's at least 60% or 80%. So you can run this in your pipeline. So when someone does a PR or does a code review, it automatically runs the tests, automatically runs. Yeah, I'll be happy to paste a link into the chat. There we go. So that is about it. So usually I do these meetups for about an hour, 45 minutes to an hour, and I want to make sure I left some time for questions. So I have the Twitch stream up if you guys have some questions. I might have answers, I might not.
And Chris, we've forked your 2 demos repositories to the stpete.net repository on GitHub as well.
Yeah, so like I said, dependency injection has a great article. I really am blown away by Microsoft's documentation. So if you do like build and deploy.NET Core applications, one of the right here, build, test, and deploy .NET Core applications, right on docs.microsoft.com. And if you come down here, run your tests. If you're doing an Azure pipeline, let me zoom in a little bit. They have not only how to build your pipelines, these are using the new YAML pipelines. So how to run your tests, hey, we're going to do a test run. We're going to publish our test results. They talk about code coverage. So collecting code coverage. And then one of the recommendations is Coverlet, which is what I was using. I use Coverlet. This is a cross-platform thing. This works on Linux, Mac, Windows, all of it. You just add that package to your test class, and then when you run the test, you run that. Another thing I leveraged to help build this out, and I'll bring up the pipeline real quick, is something called Report Generator. Report Generator is open source as well. A great project. This will take the output of Coverlet, OpenCover, Jacoco, whatever, and it will spit out the HTML or the Coverterra files that Azure DevOps uses. And you can install it as a package, install it as a tool. I'm using it as a DevOps extension, and I'll show you why. But yeah, make lots of reports, including little badges, so you can see your code coverage as a badge on your project or page. The reason, and this is what it generates, I'm using it via the DevOps extension, is because a lot of times when you see someone talking about leveraging Report Generator, they have you do a .NET Core, they have you do a line in your project to install the tools, and not everyone can leverage the tool install. And if you're doing on-prem agents and cloud agents, it can it can cause problems when you're going from a cloud hosting to an on-prem hosting. And you notice I'm in Windows. I'm building this, by the way, on Ubuntu, so .NET Core cross-platform. It's also very generic. I'm not specifically calling out my solution name. I was trying to do some caching, so let me get the right branch. Here we go. So I'm telling it to which .NET I'm using. Trying to do restore. Just do my normal build with the solution. And here's my test. I'm specifying to do a configuration release and spit out these TRX files. The TRX files are used by Azure DevOps to populate that little test tab I'll show you again in a sec, and then collect expat code coverage. So I'm doing that, and I don't want it to publish. I don't want duplicates. And if I have a failing test, I still want it to keep going. I want to be able to gather that code coverage and testing information. So I then use a report generator. This is that plugin. I installed the DevOps. It finds all of my code coverage files and testing files in all of my test folders, and it puts them all together and combines them into one. So now when I publish code coverage, I can say, publish that one file that was generated in Coverterra. This thing's awesome. I love it. And then publish those test results, those TRX files we made. And if any of them failed, now fail the build. And then that tool I mentioned that is really cool. And this will be my last thing. Sorry. I love talking about stuff. Do I not have it? Oh, I don't have it in this pipeline. I'll have to get it. Oh, if there's another question while I'm doing this. Sorry. Forgot to do something.
That's actually a big help for me because I used to, or I had been and continue to run into problems with merging test results from multiple different test projects and getting them merged together. So um, just looking at your YAML gives me some ideas on how to resolve that.
I have one for React. So I have some stuff with a client that is using Create React app, and they're using the jest tests inside of React. And so if you leverage jest JUnit as an extra package and you add that as an npm dev dependency, what that does is it lets you, okay, so I just added a task. See if it shows up. Might have to refresh real quick since I just added it. So what I would do after publish, so if all my tests pass successfully, what I usually do, if I care a lot, quality, there it is, build quality checks. This thing is awesome. I've just started playing with it. Let's say I want a warnings policy. Do I want fewer warnings this time than last time? Like clean up your code a little bit? Or maybe I want no warning, no warnings? Fail the build if there's a warning. That's awesome. Or let's say code coverage. Maybe I just want it to be better than before, up until 80%. Just be better. Or maybe I need a strict 60. Now I will point out with this plugin, and if you're using Coverlet in the report I have, line and branch work, block do not work. Okay, so if you're doing it, you have to do line coverage or branch coverage. It keeps saying 0 for block. I think it needs to come from a different type of format other than Copertera, maybe OpenCover, but this works, and I have this enabled at some of my clients. And then when you get fancy later, there's other stuff you can do. This is more for old XAML builds. It doesn't apply to new stuff. But if I click and then add that in, boom, I have a build quality check of 60% coverage. So, all right, stop sharing. Sorry, I can just keep going.
I also saw in your code examples, you had a lot of attributes over different classes and things like that for exclude code coverage.
So people will abuse that. I try not to abuse it too much. What I try to use that for, and I'm sharing again. So here, this is a class that maybe doesn't, look, there's no custom logic. These are parameters.
Hold on 1 second. Let Clayton switch the scene for us.
I apologize, Clayton. Is that better?
Yep.
All right. So if I have a model that just has some properties, I might throw an exclude code coverage here. Okay. Or I think it's exclude from code coverage. Yep. So I might throw that here because if I run this through unit testing and code coverage, what it might say is you have 4 blocks here that are not tested because there's a getter and I need to test it. And there's a setter and I need to test it. So there are cases where I might throw that on models because we know getters and setters work. There's no need to test the .NET framework against the .NET framework because it, yeah. The other thing I do is I've seen it really throw off numbers and completely freak out because it's like you're not testing your test code. And I'm like, I don't want to test my test code, like an infinite loop of yo, dog, I heard you like testing. Let me test your testing code while you test your testing code. Like, I don't want to do that. So I exclude those from code coverage. So I'm a bad person, I know. Was there? Did you have another question about that?
I just didn't know if you had any recommendations or best practices that you've come across, or you kind of went over how you structure things in
So
model hierarchy and things like that.
if I had like a class here that said like count books and it returned an int, and it was just a getter, but I had some sort of I had some sort of logic on it. I had a method here that did things. I would not exclude it because there's logic there that needs to be tested. And I want to make sure it doesn't blow up on the edge cases. Another thing is when I'm working in a bigger project, if there's a bug, I want to go and make a unit test to solve that, to test that bug so that it never comes back, so that we don't reintroduce it as a regression. We've had a bug, make a test like right away. That it's like a knee jerk now over the years. So um, I see people trying to do 100% code coverage or 90% code coverage. That's fine. I do see sometimes the startup can be hard. A lot of times we're doing setup stuff. This can be painful to try to unit test. Um, some of the controller stuff can be very hard to unit test. You have a lot of HTTP contexts and user session stuff that can be painful. I don't exclude it, but I acknowledge that some of those things are edge. Um, I also do like to try to use filters and attributes to isolate out chunks of code. So especially if it's repeatable validation, repeatable authorization, let's make an action filter or an authorization filter that can be tested. That can be isolated and tested and reused. Yeah, there's always a balance. There's always a balance with unit tests. There's discussions of Clayton. Sorry, stop sharing.
We're good.
Okay. Um, Clients always try to outweigh the balances of I want you to get stuff done. I want you to produce features and work on code. Why are you writing tests? It slows you down. What value is it bringing? That value is part of the agreement everybody made as when you're trying to get to production is this is the quality we expect. This is the definition of done. Do we want our code to be maintainable? Do we want to be able to make changes in the future? Because if we don't have a documented way of how it runs and how we expect it to run, that can break things as we start making changes in the future. If we build our tests in now, we have an understanding of what happens, and as we start making new features and changes, we have that safety net of, oh, we just broke that thing over there. Oh, we need this new integration we added just broke the whole whatever subsystem. So it documents, it makes things maintainable because someone can open a test and actually look and see how it's supposed to be used, and your changes are introducing safety, and because it's part of the pipeline, you have very quick awareness of when something broke, and not having someone tell you 6 months later that, oh yeah, that feature hasn't worked in 5 years. Whatever. So I'm a big advocate of it. Um, it's just understanding the value proposition.
Yeah, I actually worked on a project where unit testing was a line item on a budget that allowed a client to say, I don't want to pay for that. Let's strike that out.
Yeah, I consider it part of my professional process. You're not going to stand next to the electrician and tell them what to do while they're putting in a circuit in your box. So why in the world would the client tell you how to program?
Why are you putting that meter on the wire before you move it?
Yeah, that's silly. You can save a lot of time and just grab the wire.
Why are you checking the breakers off 3 times? Yeah. So, no, that's a good question. I think it depends on the client and the mindset. You can tell by the old books. I've been doing this for a long time, and I'm passionate about it. Like, that's why I like doing the meetups and speaking. I want people to be as excited about technology and programming and as I am. And I definitely have had coworkers that it's a paycheck. It could be anything. You know, they could be flipping burgers, they could be mowing lawns, they could be drawing comic books. It doesn't matter. It's just a paycheck, and there's no passion behind it. And I'm very passionate about this, and I know other people I've worked with are very passionate about it. And I think that when you see the results in the long run, there's a better outcome a year down the line, 6 months down the line, and a better onboarding and integration process as you get new people and you try to mentor people like, hey, look, here's how we do it, here's how it's written, and here's how you integrate. Yeah. So. Anything else?
All right. Any more questions for Chris?
Sorry, I cut short the 2-hour window. I'm used to about an hour, hour and a half. They do stay in business. They will definitely just keep pushing code out the door and see what happens.
All right. And how did everybody like the format? Is this working for everybody? Do we want to continue trying this while everybody's in lockdown?
Thank you guys for attending. I appreciate it.
Yeah, perfect. Then we'll be back next month with we've got a couple of options for doing more remote streaming. So we'll continue doing this. If anybody has any suggestions for speakers, any suggestions for topics, maybe even suggestions for sponsors, maybe we could do giveaways, something like that. We'd certainly be all ears. With that, we'll kind of call it quits from here. Appreciate everybody joining. We will have this video will be up on Twitch for, is it a week or 2 weeks by default?
I think it's 2 weeks, and we can also download it to YouTube. Yeah.
So we'll do that as well. So if you know of anybody that wasn't able to attend and still wants to see the presentation, then we can back it up to our YouTube channel as well. Thanks to Chris for a great presentation and putting together all the demos and slides. We've forked the demo repositories as well on the stpete.net GitHub account. So we've got all of that out there for you. Please, if you are new to Twitch, go ahead and give us a heart. What is this? A follow on screen. We're also pretty new to Twitch as well. So give us a follow on Twitch and show us your support. Join us on Facebook, follow us on Twitter, join us on YouTube, pretty much all of the social medias. But with that, thanks everybody for joining.
Thank you guys.
Thank you.